Welcome to our YouTube channel. I am G. Prabha from Department of Information Technology. Now I am going to explain about the overview of an embedded system. Objectives of our slide. This is first you should study about the definition of an embedded system and then characteristics of an embedded system and then the components of the embedded system, processes which was used by the embedded systems and its advantages and disadvantages. Okay. Now we are going to study the definition of embedded system. Before going to study the embedded system, you first define the term system. What is meant by system? System is a different parts of the different parts which was assembled together to perform some function. These functions was based on a specific rules. A set of rules was followed to perform the operation. The parts which was used to by these operations are called as a system, which was assembled together to work the function. And then you should know about the word embedded. What is meant by embedded? Embedded, as the name suggests, the something that was attached to another thing, which is called as embedded. Now the embedded system means this a computer hardware system which was embedded a software which was associated within the hardware, which is called as embedded system. Which is the embedded system is a specialized computer system to design the specific task or few tasks, specific a single task or a few tasks to be completed by the system. The embedded system, which is an independent system or which is a part of a larger system. It is a microcontroller or microprocessor based system was helped to design to perform a specific task. The embedded systems are usually used in variety of applications such as consumer electronics, medical appliances, industrial control systems, home appliances and automotive systems, etc. In the home appliances, we all should using these embedded systems. A washing machine in our home, we see a simple example for embedded system. Next, the characteristics of embedded system. The embedded systems are simplified as it is characterized as a single function system. What is a single function? That is the embedded system usually perform a specialized operation. It will be doing that operation only repeatedly doing that particular operation only. For example, pager system. The pager system helps to function only for sending a pager messages only. Next, the characteristics of embedded system is reactive and real time. Reactive and real time, that is the many embedded systems are continuously reacted to change the environment. It will be change the system environment. It will be do the necessary actions without any delay. For example, using the car cruise controller system, it will be continuously monitor the speed and brake sensors to determine the speed of the car. And then is embedded system is a microprocessors based system. It will be either using microprocessor or microcontroller to perform the task. Memory. It should be have the memory. The memory is it will be embedded within a hardware. This memory is their ROM. Basically, embedded system use a memory as a ROM memory. ROM is a non-volatile memory. No external memories, that is secondary memories, are not allowed to be used by the embedded systems. And then embedded system is a connected. Why it is called as connected? Because the components of the embedded systems are will be interconnected with each other. Each components are to be connected with interconnecting. It will be using some peripheral devices and input or output devices are connect together. And then this is a hardware and software system, because the softwares are embedded within a hardware system. The software gives used for more features and flexibility. The hardware it will be enhance the performance and security for our system. Next, we study about the components which were used to design the embedded system. The embedded systems are mainly designed by using the three basic components. Number one, hardware component, and then software component. Third one is the real-time operating system. It will be simply called as RTOS. This real-time operating system supervises the application software and provide mechanism for handling the instructions which was executed by the browsers. It will be continuously monitored by RTOS component. Let us study about the hardware components. This is the hardware component. This is a hardware circuit on a embedded system, which is a building blocks of our embedded system. Number of hardware components are power supply, reset and oscillator circuit, input devices, processor, program memory and data memory, timers, interrupt controllers, output interfacing circuits, parallel ports, serial ports, and then program memory and data memory, system application specific circuits. These all are the building blocks of our embedded system. Let us see the one by one, the components one by one. First one, power supply and reset. Most of the embedded systems have their own power supply. Some of the embedded systems do not have their own power supply. Then that will be requiring the external power supply for the startup. The external power supply, example for the external power supply, this USB based embedded systems are, the power should be supplied for the externally. Reset means the processor going to processing the instruction as a starting address. It will be set default by the program counter registers. Next component, clock oscillator circuit or unit. The clock circuit will be controlling the execution time of the instruction. How long time the instruction should be executed is determined by the clock oscillator circuit or unit. And then timer. Timer circuit is configured as a system clock, either system clock or as real-time clock. That only the operation should be performed a particular time period. And then next component, program data and memory. Program data memory, that is, it will be computer system must have a memory to storing the programs and data. That memory should be the internal memory. May not be using the external memory for that embedded system. The internal memory which was used by embedded systems are RAM, ROM, flash memory, EEPROM, that is electrically erasable programmable read-only memory, EEPROM, erasable programmable read-only memory, PROM, programmable read-only memory for storing programs and data on our embedded system. Next, the important component used by embedded system is interrupt handler. Interrupt handler, since we having this is one of the major device to controlling the interrupt. They will be handling a single interrupt or multiple interrupts simultaneously. And then I/O port. The I/O port are used to provide interface for the external devices like sensors, key buttons, transducers, LEDs, LCDs, alarms, motors, printers, such as the peripheral, such as input, output devices and peripheral devices provide interface arms. There are two types of ports are used by embedded system. One is a parallel port, another one is serial port. The parallel ports which are used in short distance communication, while the serial ports are used in long distance communication. The next component, input-output device interface or driver circuits. That is, some I/O devices such as motors, actuators, valves, sensors, they are not compatible to connect with the embedded processor. Such type of input-output devices are connected via the interface unit. So, providing the I/O interface circuits are designed for such input devices are to be connected to our embedded processor. And then system application specific circuits. These system application specific circuits are controlling the target circuits such as ADC. ADC means analog to digital converters. When the application require to convert the analog signals to digital signals, then it will be needing this type of circuits, analog to digital converter circuits. Another one is digital to analog converter. When the application which requires the digital signals are converting into analog signals, then it should be using the digital to analog converters. Apart from these two circuits, also using the relays and sensors. They are called as application specific circuits. It was used by our embedded system. The last and most important component of our embedded system is bus. What is meant by bus? Bus is a collection of wires that will be enable the communication between the components of our embedded system. Will be hardware components or communicate each other with the help of the bus. The bus that can be enable the transfer of data and control signals between various modules like peripherals, memory devices and microcontrollers. That's all about the hardware components of the embedded system. Now we are going to study about the software component of embedded system. The software is a set of programs which will be helps to execute by executing by browsers. It will be embedded within a hardware unit of a hardware unit, which is called as embedded system. This software, this is a set of codes and data which are associated in a set comprises to form the software. This software are stored in a memory which is called as ROM memory. This ROM or flash memory, this is the final stage. This final stage of this software is embedded. This coding is embedded in memory. ROM memory is called the ROM image. This ROM image is the arrangement of ROM address of bytes of instructions and data. This ROM image consists the following programs for handling the specific task. The programs are associated within the ROM memory. The ROM memory, that is the ROM image. Boot up program. Boot up program helps to boot the device. Embedded device helps to boot the embedded device. And then stack address pointer. Stack address pointers to store the stack address pointer helps to store the return address of the functions calls. And then program counter register, the address of the next instruction to be executed by browsers or executed by processors are stored in program counter register. And then application programs, this is the final program to run our task. And then ISR means interrupt service routines, which was handled by the interrupt service routine handler. And then RTOS, real-time operating system, will be managing the overall function of the system. And then input data, the input data for receive the input which was given by the user. And then vector addresses to the collection of inputs received by systems are stored in these vector addresses. These all programs is a part of our ROM image. This ROM image, all the programs are, how the images are to be stored. All these images are stored in bits or bytes format. That is the bytes at each address, it will be creating the ROM image. By changing this image, the same hardware is used for multiple applications. That it will be using the different application and to upgrade our system to a new system by simply changing the ROM image. But the same hardware components will be used for the different applications. The ROM image, that is the programs which was stored in a ROM, are either in compressed form also. If it is stored in a compressed form, we also needing the decompression algorithm for decompressing the programs and datas. Okay, next we move on to the embedded system processors. What is a processor? Processor is a heart of the embedded system. Not only embedded system, it is a heart of any other computing system. It is a basic unit. It will be receive input from user and process the input and produce output, which is a result. In the embedded system, designer must know the knowledge of using the processor, microprocessors or micro handlers to handle the data and codings. It will be processor has two essential units. Number one, program flow control unit, which is simply referred as CU, and then execution unit, which is called as EU. This program flow control unit, it will be fetch unit. It also called as fetch unit. It fetch the instruction from memory only. The execution unit, it will be executing the instruction which was fetched by the fetch unit. It process the instructions. It also having the unit is a ALU, arithmetic and logic unit. It performing the arithmetic and logical calculations with the help of this ALU unit. And it also have some circuits. That circuits are specially designed to handling the interrupts and some other jump instructions to be handled by these circuits. Next, the type of processors which was associated with our embedded system. The processors can be the following categories. The following categories of processors are used by our embedded system. General purpose processors, example, microprocessor, microcontroller, embedded processors, digital signal processor, DSP, simply called as DSP, and then media processors. This is all are categorized into GPP, that is general purpose processors. Second category, application specific system processor, ASSP, and then application specific instruction processors, and then general purpose processor, core processor, or application specific integrated processors, instruction core processors, either application specific integrated circuits or VLSI chip, that is simply called as very large scale integration circuits. These are all type of processes which can be used by our embedded system. The advantages of and disadvantages of using embedded system. Advantages: embedded systems are easily customizable, and then power consumption is very low, cost is very low, and then it provides enhanced performance at a low cost. The disadvantage: it will be high development effort to be taken for designing the embedded system, and it will be taking lots timer to marketing our product. Thank you, girls.